Hi, everyone. Thanks for joining in on this session of the 2021 Maryland State Firemen's Association's virtual conference. I'm your host, Christopher Naum. Our program on this session is the influence of building construction and occupancy risks on the fireground, an evolving built environment, a demanding fireground. Our program is a short conversation related to today's demanding fireground and emerging challenges from the evolving built environment, building sciences, and learnings from research and the hard fireground lessons. Our virtual online program is an abridged lecture from the full 8-hour seminar program series of which this program has been extracted from. Provides a general overview and insights related to the influencing factors of building sciences, construction, and emerging research and development on fireground decision-making, as well as some suggested modeling that we're going to be providing toward the end of our program. The program has been edited for online delivery and for the virtual program time. Our program, as the title describes, deals with the evolving built environment and the demanding fireground, of which there's tremendous interface. When we talk about the evolving built environment, there's certainly so much going on in so many jurisdictions, certainly throughout the entire United States, and certainly in many of your jurisdictions for those of you that are operating here within the state of Maryland. The evolving built environment presents numerous challenges, and they all start and rest solely with the characteristics of the buildings, the methodologies, the materials of construction, and the evolving nature in which fires evolve within the compartment and ultimately affect the building. That ultimately lead to a demanding fireground. When we talk about our responsive resources, the manner in which we engage within the structures and the built environment, and certainly the many challenges related not only to the fire suppression activities, but also related back to building performance and our level of engagement. For those of you that don't know me, my name is Christopher Naum. I'm a 40-plus year fire service veteran, former fire officer, architect, fire protection engineer. I've worked in all capacities throughout my career in a variety of either concurrent or separate tracks. I currently serve as a technical advisor and subject matter expert to NIOSH's Firefighter Fatality Investigation Program. I serve both as a technical advisor and help support a number of research studies, as well as the issuance of the various line of duty death reports, so specifically focusing in on building construction, building performance, and fireground operations. I've had a very robust level of involvement within the fire service, again, in 3 allied professions, both the fire service, the fire protection engineering side, and then for a short period of time within the architectural side, working as a project architect. So again, I look forward to your insights into the program here as we present it. And again, they're rooted in all 3 disciplines that we're providing some insights, especially as they relate back to the emerging opportunities that research and development is giving us, and how they truly correlate back into our fire suppression and fireground related activities. Since it is an abridged program, we do have a number of resources available to you online. Again, these are non-commercial in nature. Buildingsonfire.com. We do a program typically on a monthly basis on fire engineering, blog talk radio. Taking to the Streets is our radio program. And again, we talk specifically about a number of different attributes related back to the built environment, building construction, integrate that back into fireground operations. If you go into the archive programs, you'll find a number of exceptional programs over the last couple of years. We ran a 3-part series on row house construction and operational insights, talking about leading into the line of duty deaths and near misses that have occurred over the last number of years, and then talking about some of the more current trends and issues affecting that. We do have a couple of other programs that you may find of interest, dealing with the 23rd Street fire in New York City, which occurred in 1966. That led to 12 line of duty deaths, as well as the Wall Bombs fire that occurred in 1978 that led to 6 firefighter fatalities as a result of operations in a commercial building. We do have a number of other things rolling out here very shortly. Our Buildings on Fire lecture series, again, will be rolling out within the next couple of weeks, certainly within the next month or so, or early part of the summer. That lecture series is part of our Fireground architectural webinars that'll be both podcast and webinar based with lectures, research, some learnings, some training on the anatomy of building construction, really formulating and looking back at the ABCs of building construction in a very robust level. And then two other program areas that you might find of interest are Buildings on Fire on Facebook and our Twitter account at Command Safety and at Buildings on Fire. Both our social media presence, again, focuses in on reading the buildings, everything dealing with building construction and trying to give you the tactical edge relative to understanding the built environment and, more importantly, interfacing that built environment with firefighting operations, which again continues to be a widening gap relative to knowledge and what we call both building and fire literacy. Some of you may have some questions or other research items that you may have interest in after our short seminar here today. So again, we're providing both an email address, cell phone number. I do encourage you to reach out to me if you do have some additional information that you're looking for, especially on the modeling and some of our building facts concepts. Again, I would encourage you to send me a questionnaire, get a hold of me via either one of those two avenues, both cell and email address. I look forward to helping support your research or questions and informational needs. And this leads us to our conversation. We're talking about the built environment, talking about the fire ground and the influence predominantly of that built environment on the fire suppression efforts relative to both training, curriculum-based, and more importantly, the operational challenge affecting the North American Fire Service, and certainly the American Fire Service, specifically when we talk about the emerging aspects of construction, the evolving nature of activities and so forth, and trying to provide some of those insights in greater than 8 seconds and 144 characters. Each and every day, the American Fire Service, the North American Fire Service, stands ready to respond. But there are significant challenges based upon the composition, the makeup, the nature, the risk factors, the operational demands, and more importantly, the environmental infrastructure that our communities represent, the fabric of our built environment, and those related demands associated with emergency response. Each and every day, again, our challenges are based upon the increasing need for knowledge and skill sets, capabilities, the frequency, severity of our operations and risks, and the challenges that are all associated with the built environment. Each and every day, companies and resources and personnel respond to a variety of different types of buildings, structures, and occupancies, all of which have varying levels of risks and demands associated with the age and vintage and the type of construction that they may entail relative to the communities and the response areas within those particular jurisdictions. But what we have seen dramatically is the increasing challenges associated with the types of evolving structures, both new and old, the insights that research and development is giving us relative to the environments in which we are operating, and the continuing challenges associated with the emerging building sciences that are creating structures and occupancies that are unlike any that we've seen in the past, although similar in nature by virtue of some of their characteristics, but yet the architectural designs, the engineering and civil engineering designs that go into our structures is evolving relative to a number of different attributes that we'll identify during our program here today, and provide some suggested holistic approaches toward both curriculum, training, and more importantly, modeling aspects, both in terms of identifying risk potential on the fire ground, how that can manifest itself and create additional challenges relative to the uncertainty of not being able to classify clearly building structures, occupancies, identifying occupancy risk versus occupancy type, and again, some of the aspects dealing with the emerging nature of our building sciences regarding the architectural designs that are going into our buildings that is creating an entirely new type and variety and variation of structures out there that the fire service has yet to develop best practices or even to develop the skill sets necessary to be able to effectively and safely handle those particular operations. We talk about our residential types of structures and the demands associated with the bread and butter operation that the American Fire Service has come to know, but also the issues affecting both commercial and involving other types of structures of a larger footprint, complexity of construction, both protected, unprotected types of conditions and so forth, all of which may manifest themselves into significantly challenging operations in which our resources and our personnel are responding to each and every day. Even something as simple and as innocuous as that residential structure, which was formative to the operations of the American Fire Service for decades, has evolved into something significantly larger, both in scale and in footprint, as well as in complexity of design, construction, engineering principles, and the delicate balance between those conditions that allow these buildings to be built, the materials and the methodologies of construction, coupled with the associated demands that are associated with compromise, collapse, building integrity, and the environment in which the fire service is required to operate within in order to protect the life and well-being of our civilians that we are sworn to protect. Yesterday's Fireground, when we talk about some of the challenges and issues of the yesterday's Fireground, continue to challenge the fire service relative to yesterday's fires as they relate to today's demanding conditions and today's Fireground. We still have our single element resources responding with limited capabilities of personnel as such, and as a result of that, we also see the increasing demands associated with the evolving nature of our buildings, with related conditions of our occupancies, and again, the challenges of those buildings and construction and features that are a result of architectural design, engineering applications, and those conditions that evolve as a result of fires developing and ensuing within the structures. What starts off as a type of fire condition, more often than not, leads to another resurrection of that same building within the same footprint, and more than likely similar types of challenges. Today's Fireground is evolving tremendously. When we take a look at the types of calls and the volumes and the severity and the urgency, the complexity and the demand sometimes are overwhelming. Certainly this is not the Fireground of the 80s and 90s, or certainly even the earlier 2000s. The evolving nature of the Fireground relative to the conditions that are present present operational challenges, risks, and demands. And again, how do we identify, how do we assess, and how do we manage those risks in buildings that we are trying to classify and relate to previous successes that may no longer be applicable? And that's part of the continuing challenges, just even in terms of reading the building and identifying many of those challenges and aspects. How do we manage, how do we control our personnel, our companies? How do we command, and how do we facilitate safe and effective operations based upon the evolving nature of our buildings, the evolving conditions relative to fire within our compartments, and more importantly, how do we establish and recognize the importance of much of the insights that's derived from the research and insights that are coming out of R&D. And that's part of our challenges, is that we have such a wealth of information in trying to filter and sift through that and make it applicable to the regional or localized basis without taking a look at trying to marginalize it, or more importantly, trying to create a uniformity on a national basis that may not be applicable to the local or regional basis. All have variable levels of risk, different margins of safety. They have both inherent, induced, introduced, apparent, perceived, real, overstated, respected, not recognized, neglected, or dismissed, or rationalized levels of risk. And that continues to be part of the challenges. We are expecting the same performance of our buildings as they presented themselves 20, 30, or 40 years ago, or certainly in the more current modern era from the 80s and 90s. We still are expecting our buildings to perform in a similar fashion that allowed us to work within the confines of those structures, in many instances without a level of appreciation for the time duration in those particular elements. But again, when we take a look at those levels of risks, again, those risks may not be the same relative to the perceptions of the various individuals and the ranks and organizational structuring operating on the Fireground. There's also a terminology that we utilize in terms of bravery versus bravado. And that also creates a level of both being risk prone or potentially being risk adverse. And that continues to be a very dynamic challenge in which different sides of the perspective or spectrum may influence operational decision making and influence the degree of engagement on the fireground. All have lessons and learnings. When we take a look at learnings and insights, they have a precedent, they have historical context and basis. But again, what does that influence? How does that influence what we call conditioned tactical reflexes and our ability sometimes to recondition the tactical perspective, the tactical reflex on how we address and both in how we assess and how we address mitigation and controlling aspects on today's demanding fireground. Again, your conditioned tactical reflex may be correct. Is it faulted? Is it inaccurate? Or is it spot on based upon lessons and learnings and the applications of some of the information that's coming out, certainly over the last 10 years, relative to the emerging nature of R&D that's certainly within the confines of the American Fire Service presently. Today's buildings and occupancies present increasing challenges that have redefined strategic and tactical fireground operations, and it's suggested have changed the rules of engagement in structural firefighting incidences. And it doesn't take much if we keep track of what's occurring, certainly within our news and social media online, to see the adversity, the challenges that are affecting, certainly the adverse trends that have been associated with construction site fires, especially dealing with our newest and emerging building type with our podium type construction systems and assemblies and those associated occupancies. But again, these evolving adverse trends relative to building types and emerging aspects of construction all are new to the fire service, to our commanding officers. And again, there is a gap relative to construction features and engineering principles and architectural design factors in what goes into our buildings, and again, have unproven different tactical approaches that may challenge conventional means of both engagement and operational aspects to that. It has become much more than just stretching the line and going in. The challenges and demands of our buildings on fires really requires a different perspective relative to both curriculum development in terms of the skill sets that are necessary on today's both demanding and evolving fireground, specific to the evolving nature of our built environment, then also different sets of parameters or templates regarding how we both identify, assess our buildings and our structures, how do we identify occupancy types and the associated occupancy risk, which is more important now more than ever before relative to the trends and conditions going forward relative to our built environment and the integration of our fire suppression activities. So again, the challenges and the gaps that are clearly identified over the last 10 to 15 years continue to increase relative to the gaps that are associated with the need versus what we are currently working with and the conflicting paradigms relative to not only best practices, but methodologies and practices that have been institutionalized certainly over the last 40 to 60 years, but more importantly, even in the modern era of the fire service over the last 30 to 40 years, we see the conflicting nature of what we have been conditioned to expect, are conditioned relative to tactics and operations, the strategic approach, but more importantly, the degree of engagement. What's now acceptable, what should be acceptable in the assessment, the risk assessment, the assessment and profiling of our buildings, the risk assessment of those structures that have an influence certainly on the suggested decision-making processes and those options. We are at a point now where our operations truly require a much more adaptive perspective toward our operations, but yet we have struggled to identify the tools that are necessary to give us those insights, and more importantly, just trying to connect the dots. How do we connect the dots with the emerging aspects of research and the insights that's coming out of research and testing and all of that information that comes out of the empirical science-based arena? And how do we relate that back to street level operations and the challenges of those paradigms that are very well established, unfortunately, in many jurisdictions around the country? Now, with that being said, There still are many organizations that are making strides and moving forward in adapting to the variety of different conditions, especially with the evolving nature of construction. As new construction and occupancies go up, they are recognizing the change in both in terms of materials, methodologies of construction, the potential susceptibility to increasing challenges on the fire ground. Those increasing challenges, when we talk about the emerging nature of that, regarding susceptibility to compromise and collapse, the variation of both construction and methodologies of our building sciences and how our buildings are being built, the changes in both architectural and engineering principles that are going into our structures, whether they be residential or commercial, again, are changing the manner in which our built environment is going up, and certainly impacting both concurrently and in the future with the types of fires that become involved within these particular occupancies and the methodologies and practices that are implemented in the street. It is much more than just stretching the line and going in. If you're going to command or tactically engage at a structural fire, you better understand the building, the fire, and your companies. Those are three critical elements here that form the basis of both our modeling and form the basis of much of what we have been advocating, certainly over the last 20 years nationally. It's all about the building, it's all about the compartment, and it's all about the companies. Three fundamental areas that we've connected the dots on and utilized as a foundation basis for other elements dealing with what we call the adaptive fireground management model, which we plan to share with you in this particular session. There is limited margin for error on today's evolving fireground. And again, when we talk about that limited margin for error, we also talk about the fact that errors and omissions are very unforgiving. And it's even more so and more apparent when we talk about the limiting margin for error on today's fireground is razor thin at best. And we use the analogy of certainly back in the 1980s and 1990s, there was a margin of error that was certainly much greater when we talk about the latitude of the operations and what we had available to us relative to errors and omissions. We could have errors and omissions on the fireground, but yet they were recoverable. Our errors and omissions today, for the most part, are razor thin at best, and errors and omissions are unforgiving and may not be recoverable relative to those operations. Increasing operational capabilities, operational excellence, we do have a movement going forward looking at and increasing some of the issues on human performance, both from the performance metrics side, knowledge, skills, and ability, some of the quantitative and qualitative elements to help reduce errors and omissions, and that whole human performance side, which was really born out of the concepts that were developed back in the mid to late 1980s with the emerging element there of crew resource management. So crew resource management, near miss reporting, they are very well established, certainly in a number of other professions, both the military, aviation, and certainly the nuclear industry. But again, we are still struggling to implement them to the degree necessary in the fire service that will provide some optimization and certainly increase performance and operational capabilities going forward. There are certainly some strides and efforts being made by the International Association of Fire Chiefs relative to expanding some of those elements on human performance, or HU, within the areas that we're very familiar with dealing with our near-miss reporting system. We take a look at the emerging aspects of research and quantitative and qualitative areas. Again, research and data, the whole aspect of research data, position statements. There's a push, there's a pull. Sometimes there's a direct correlation, there's clarity, and then many times there's confusion and conflicting related conditions. And we constantly see these issues dealing with, again, are they just today's leading issues and problems? And really the response is no, they're not. We continue to see the evolving cyclical nature in which research, data, and position statements have always been there that continue to, again, push, pull, direct, provide clarity, or provide confusion or conflict. And those conflicts are always there, and there's always and always will continue to be challenges, hope, or despair as we go through these cycles of the evolving nature of technology being identified and how it becomes eventually institutionalized within our practices and methodologies. But we are certainly seeing a tremendous degree of dynamics currently within the profession, certainly over the last 10 years, and more importantly, even within the last 5 to 6 years, where we've seen the conversations increase, the dialogue, and certainly also the degree of conflict because of the lack of knowledge, the lack of clarity, or what we call the degree of illiteracy, just not comprehending the complexity of some of the information that's coming out through the research areas that are more scientifically based, empirical based, and such, that are, again, creating conflicts with those that have a fear only because they may not be familiar with the nomenclature, the details that are coming out, and being able to apply it within the context of a profession that really has engaged and provided an integrational point of that for many, many years. We have fire protection engineering that's certainly nothing new. It wasn't invented of recent, but again, we have neglected to take a look at the rich degree of fire protection, both research and engineering insights that have been around certainly since the early turn of the century in the early 1900s. Some of the development of emerging research in the 20s and 30s, and certainly the rich development of that research and data, the 40s, 50s, and 60s, continue to be derived, and certainly the efforts by Underwriters Laboratory, NIST, and many other organizations that are part of the establishments that identify, distill, and provide further insights. And more importantly, many of us that continue to take those insights from research and try to identify methodologies and practices and modeling to make it more palatable, both understandable to the American Fire Service for the street level firefighter. And part of the challenges include, how do we raise the bar on knowledge, skills, and technical competencies, which is really part of the problem. There truly needs to be a greater degree of emphasis placed on higher degrees of technical competencies, especially at the command, and then thusly underneath that at the company level of the organizations of supervisors and managers. But certainly, if there's one specific group that does require the need for a higher degree of information and technical competencies relative to the decision-making process, and that's certainly at that command level of our organizations. But again, when we talk about the cyclical nature of science and research and data, again, there's always been that negative attribute dealing with, there goes the job, there goes the fire service tradition and culture. But again, we continue to see the old adage of 200 years of tradition unimpeded by progress, and we see these cycles. What's new, what's old again, continues to go these cycles. And it's really important for all of us to stay very relevant, and more importantly, seek out the ability to apply the lessons and learnings that are coming out of line of duty death and near misses, after action reports, and again, the information, most importantly, the information coming out of research, science, data, and those insights. The evolving nature and complexity of our built environment demands of us to have a greater degree of insight relative to architecture, construction, and engineering. It's certainly the basis of everything that we do when we talk about the built environment and the integration of structural firefighting efforts. The challenges that we talk about are mission critical. What's on our radar screen? What are the involving elements? As such, there is a wealth of information that continues to be publicized and has been available certainly for a number of years now. And certainly when we take a look at the early days of the emerging first series of reports out of NIST and UL, again, 2004, 2005, 2006, and where we have come from here in 2021. There's a wealth of information. There is a significant amount of best practices that has some runtime in the streets and organizations based upon training development, a holistic approach toward it. More importantly, just how do we take and implement much of these lessons and learnings that science and research is giving us and apply it within the realms of our organization. The challenge really becomes, how do I take it and apply it to my organizational setting that many of you are struggling to do, and not one size fits all, which is part of the continuing challenges out there. More importantly, the other challenges, again, relate back to the built environment and the fire ground, where we no longer just have routine natures of fires. We are seeing the importance of the fire load packages within the confines of the compartment and how they relate back to the overall integrity of our building. One of our concepts that we've introduced a number of years ago relates back to the integrity of our buildings. We talk about operational parameters of our built environment that truly influences decision-making parameters and characteristics. And that deals with the performance characteristics of our buildings. First and foremost, all buildings truly are predictable in nature relative to their performance if we have an identification of some key parameters that, again, filter out the background noise, provide some clarity and focal point on the key elements that affects a building relative to fireground operations, and also considers both the anecdotal as well as the empirical data that's out there. We can't exist without each one separately. Each one truly has a level of integration that should rely on each to help support those particular efforts. One may, again, provide validity and further support, but at the end of the day, the manual efforts of firefighting within our built environments does require some of the manipulative manual efforts that is just necessary as a result of manual structural firefighting engagement within that structure, but it has to be balanced out. It has to be balanced with a clear understanding of what the risk factors may be, and going in with a full degree of knowledge of what we expect to accomplish relative to our mission, the task activities, but more importantly, just have an appreciation of the severity of that risk in terms of what may occur, and an understanding of the severity, the urgency, and the growth of that fire within the compartment and the fire within the built structure. So we talk about the aspect of RIT, and we'll explain a little bit of that further in our latter portion of our session. But the concept of RIT is not associated with the emergency response and safety of our firefighting forces as it's typically come to be known, but RIT relative to our built environment, our structural fireground, and more importantly, our adaptive fireground management model deals with identifying and associating with our structure the degree of resiliency, resistance, integrity, and time. It has everything to do with the aspects of the building, the compartment, and the company. So it goes back to the fundamentals of what we mentioned very early on in our opening statements, is that everything in the fireground truly becomes associated with both the building, in terms of the structural firefighting aspects, the building, the compartment, and the companies, those that are going to be engaging within the structure. We'll explain that a little bit further here in a moment, but ultimately the building's integrity relates back to some very common and identifiable principles relative to resiliency, resistance, integrity, and time. The resistance and resiliency of components of the compartment in which firefighting activities may be undertaken. It's also the integrity of structural components and elements within that occupancy, within that structure, and the associated degree of time that's allowed or allotted based upon the degree, either positive or negative, to resistance and resiliency, integrity factors, and operational tactical windows. So clearly, when we take a look at, number one, introducing the concept, and then secondly, introducing the concept and applying it to the application of tactical operational capabilities at the task level, and how that consideration, how both the identification of building parameters, both inherent or other factors within the building, how do we identify those factors within the structure based upon building anatomy and building sciences? How do we relate that back to the science that we are gaining greater insights on relative to the fire load packages, the heat release rates, and again, the emerging aspects of how we suppress fires within these confining environments, within the occupancies, and within the compartments itself. It's all about that room, that compartment, and the structure itself that forms, again, both the perimeter walls, the floors, the roofs, the compartment itself, and the associated voids of the structure. 5 key elements there that, again, are no longer just routine levels of operations. What's new and what's old, we take a look at some of the leading organizations that are certainly applying a tremendous degree of insights toward our operations. And again, it goes without saying, there's a tremendous amount of effort along with numerous organizations and professional associations that are all trying to move that ball forward. And again, although we pick up some yardage at times, we also end up losing some of that yardage just based upon the push and pull of and movement and the ebb and flow of acceptability, learnings and understandings, the dialogue, and then certainly some of the efforts that are being developed through the campaigns and the initiatives that takes research, science, data, and insights and places it into practices and modeling and methodologies that help support the aspect of firefighting and fire suppression activities and operations. We take a look at some of the evolving elements, certainly with UL and NIST over the last number of years, again, going back all the way to 2005 with some of the first emerging aspects. But we've certainly come a long way when we take a look at the various types of research and studies, and more importantly, the data and the insight that those studies have given us, all which is supporting a variety of different initiatives. And some of these actions and studies have truly moved forward and really created a wealth of not only insights, but its application relative to how we've actually started to institutionalize that relative to the methodologies and the practices within the modern fire suppression service system and setting. Some of those elements, again, tactical considerations: vent path, flow path, basement fires, compartment fires, attic fires, pushing fires, not pushing fires, going back to pushing fires. I mean, we constantly see the evolutionary process as more insights either continue to validate the assumptions and the presumptions and those findings, or they also, in turn, may prove to provide a degree of no longer being valid because of other insights that come about. But again, we just see the tremendous element of efforts. We are certainly moving forward, have a greater degree of understanding of our fire load packages, which certainly from my standpoint, when we talk about structural integrity and operating within the built environment, it goes well beyond what we used to talk about in terms of room and content fires and BTUs. Now we talk about them relative to different units of measure in terms of our megawatts of energy, but more importantly, how that now relates back to water mapping and sustainability and suppression capabilities and actual mitigation efforts. We are moving forward with a much greater degree of insights and learnings, and again, trying to apply them relative to our methodologies and practices. Transitional attacks, again, that whole list here relative to both controversial as well as those other elements here that ultimately go back to go and no go, our slicers, dicers, and nicers, and I say that certainly with a little bit of tongue-in-cheek application to it. But when we take a look at all of those elements, again, they continue to be influenced by facts and opinions, suggested guidances, or again, taking a direction. Some things are taken out of context or out of scope relative to the R&D, the extrapolation. They're no longer applicable to the local profiling, the rhetoric, the bandwagon, the influence of social media, the influence of data points and taking them and applying them into our practices, the rapid implementation sometimes without the field runtime is part of our challenges when, again, we have a status quo that identifies a particular theory, identifies a potential practice, and then moves it forward, gains momentum and traction, and suddenly, again, there is a lot of fanfare, people jumping on that bandwagon, and again, sometimes it may be premature, or other times we are just slowing down and moving so slowly that we do need that requirement to make leaps and bounds into it. But it is part of the challenges relative to that rapid implementation, or sometimes the conservative nature of what rapid implementation may suggest. We have a loss of dialogue at times, the debate, the implementation, the review, and the adjustment. Don't have any degree of soak time. There's no true best practices as of yet because of the limitation of field runtime, but we continue to strive to connect those dots, and that's part of our dialogue and discussion here in our session. How to connect those dots and provide validity relative to the next study, or connect those dots so that we take the aspect of science and theory, the influence of what we are seeing, and apply that into our evolving, challenging, and dynamic fireground currently. And again, true empirical and applications, we are not internalizing them to a great degree, and certainly the challenges of our paradigms, the indifferences, and sometimes truly the ignorance that's out there. We truly need bold steps, leaps, and bounds to boldly go sometimes where no man or woman has gone before. But again, we are making strides. We are seeing the implementation of research and science and data points. We are seeing how all of these have made significant inroads into everything that we do. Just recently, the NFPA 1700 standard, which was issued, our guide for structural firefighting strategy and tactics and tasks, that are supported by science-based research. And certainly that is a significant achievement when we take a look at what's occurred just within the last 10 to 15 years duration of time, where our paradigms continue to be challenged from that particular perspective. The continuing challenges are such that, again, when we take a look at operational excellence, the trends that are out there, we take a look at some of those issues, there are many organizations or influencing groups that have a degree of ignorance. There's false leadership, sometimes the level of being illiterate regarding that. There's an intoxication by tradition that certainly infects that, and there's certainly some of the aspects of toxic groupthink and sometimes the self-perpetuation of some of those beliefs. So there's certainly efforts that are working to continue to drive things. It's highly suggested in a negative direction, but again, they are opinions. They all lend themselves to the robust and appropriate dialogue that the fire service truly needs to be able to move forward in a collective and cohesive manner. But again, achieving operational excellence, it's just not that simple, or is it? We talk about embracing research and development. We talk about identifying the applications, seeking the tactical edge, as I call it, and also taking a look at those that are the influencers, having adaptiveness, and more importantly, having resiliency to both look at best practices and identify those types of conditions that may help us move forward in an appropriate manner. The integration of technology and the information, change management, decisive planned change management, utilizing research, utilizing our data, utilizing our insights, recommendations. So anytime we take a look at change management, it has to be decisive and just have a good, effective change management plan, the recommendations, utilizing the best practices, having the development of a program, having the initiatives, and again, having both literate, informed, and conversant types of activities within the organization, its application, and certainly the aspect of adaptive phased management toward the operations to provide innovation and progress in the organization. The continuing challenge is, how do I know what I don't know if I don't know it? And that truly becomes the efforts both at the command and company level when we talk about these particular considerations. It needs to be much more than luck when we talk about the operational challenges and issues. Some of the issues that are currently affecting us when we talk about our built environment include residentials, large area residentials or mega mansions, our multiple occupancy dwellings, the evolving nature of podium construction, the mixed use occupancies, commercial buildings, typically of 30,000 square foot or less relative to size and footprint, the modern retail, service, and building and business type buildings, the hybrid structures, the adaptive reuse and reutilization of our buildings, the renovations, conversions, and alterations, and certainly evolving nature of mass timber, CLT, cross-laminate timber, and the associated hybrids that are coming about as a result of them, which all equate to the concept of occupancy risk versus occupancy type. There's an immediate need for today's operating command and company officers to increase their foundation of knowledge and insights related to the modern building construction and engineering, to fire dynamics, occupancy risk, and fire protection engineering, and to align traditional and conventional strategic operational methodologies and proven past practices to modern research-based insights and refined operations and tactics in order to safeguard companies and personnel and increase operational capabilities. It's pretty simple, but yet the challenging nature of that. Our good friends in the Framingham, Massachusetts Fire Department, again, extend and have a greater degree of appreciation. They're going out into the field, looking at the emerging type of construction that goes well beyond the traditional types of New England-based construction and occupancies. And again, the changing nature, understand intimately, again, the built environment and the fire phenomena, prepare, dialogue, discuss, and again, they're going out into the field, identifying, asking questions, looking at the emerging nature of construction and preparing themselves through dialogue, conversation, and through the enhancement of their SOPs, operational guidelines, and through their training environment. And again, increasing the integration of the human performance element from that operational standpoint. The one thing we need to recognize is that there are different viewpoints, and those different viewpoints, all the way from the firefighter all the way to the commanding officers, there's different risk tolerances and perspective when we talk about these types of potential changing nature, and even in terms of just assessing and identifying a building relative to fire involvement. How am I going to size up the building? How am I going to read the building? That becomes part of the challenges, and again has resulted in a suggested modeling approach. The aspect of building construction is pretty straightforward in terms of its importance, and the analogy that I utilize is that building construction is as fundamental to structural firefighting as water is to fire suppression. So again, it's pretty straightforward. Building construction is as fundamental to structural firefighting as water is to fire suppression, but yet we do not we do not put anywhere near the degree of emphasis on construction and engineering principles, both civil, so architectural, civil engineering, and fire protection engineering principles and concepts at the command level, and certainly at the company officer level with a slightly diminished degree of intensity. But those particular needs in terms of truly understanding our built environment all are fundamental to our fire suppression operations as water is to fire suppression. But again, when we talk about all these different elements here, the question that comes to mind, or certainly the challenges that always seems to pose itself, is that has it all changed? Has the Fireground changed relative to what we're talking about here? And that becomes the $50,000 question. Has it changed? Has it changed relative to our construction, our methodologies, our practices, our company officer capabilities, our knowledge base, knowledge, skills, and abilities? Some would say yes, some would say no. There's certainly a lot of controversy, but certainly the complexity of construction or occupancy changes certainly have affected to a great degree operational capabilities as well as operational parameters relative to what should be done, what can we do, and how do we do it. So the question is this: has the Fireground changed? Each year, a sizable percentage of the number of firefighters killed as a result of structural collapse. There are cases on record where the deaths from collapse were a direct result of faulty size up by officers because of their lack of knowledge of building construction, fire behavior, and the rate of water application needed. Certainly a truism if we talk about in dialogue much of what's being discussed today relative to those three specific areas, and especially as it relates to R&D. Chief Lloyd Lehman wrote these words in his book on firefighting tactics in 1951. So again, we see the cycles, we see the changes of the built environment coming out of the post-World War II era, and the same issues dealing with emerging construction, fire behavior, the rate of water application, and certainly Lloyd Lehman as an innovator identifying the indirect attack, also identifying little drops of water and the fog stream applications in an environment, in a paradigm and in culture that was highly resistant even to the conversations that were taking place. But again, we just take a look at those particular elements here as they were published in that very small, innocuous book in 1951 on firefighting tactics. Another couple of words coming out of real-world experience are this, and indulge me for a moment here as I read through it, quote unquote. If you don't fully understand how a building truly performs or reacts under fire conditions, and the variables that can influence the stability and degradation, the movement of fire, and the products of combustion, and the resource requirements for fire suppression in terms of staffing, apparatus, and required fire flows, then you will be functioning and operating in a reactionary manner. This places higher risk to your personnel and lessens the likelihood for effective, efficient, and safe operations. You're not just doing your job effectively, you're at risk. These risks can equate into insurmountable operational challenges and could lead to adverse incident outcomes. Someone could get hurt, someone could die. It's that simple, it's that obvious. We take a look at those words and the meaning behind them, and we take a look at quote unquote. These were the words of Chief Anthony Aiellos, who retired out as the chief of the Hackensack, New Jersey Fire Department, who lost 5 firefighters in the Hackensack Ford fire of July 1988. He wrote these words on an anniversary, subsequent year anniversary, but they resonate with everything that we talk about here in this session and everything that we should be striving for when we talk about the integration of building sciences to fire suppression activities and the true importance of what the building sciences, building construction, and the integration of fire protection principles and engineering sciences into that study of knowledge, skill set, and technical competencies, but also in our methodologies and practices on the fire ground. We are seeing a tactical renaissance, or is it a tactical inquisition? Some would say one, some would say the other. They are certainly dynamic and engaging times, but again, do we have proactive engagement and contribution, or do we have obstinate observers watching passively from the sidelines? And again, when we take a look at the conflicting natures that we either embrace or collectively embrace and move forward, there are collaboration and a shared vision, but at the same time, there are conflicts. And Paul Combs provides a great image here when we talk about experience in science and some of the disruptive nature when we talk about moving forward in unison to identify best practices and move forward regarding what we are seeing relative to the insights from research, science, and data. But many times we hear the same analogy or the same comments that come out that says, don't confuse me. All I want to do is what? All I want to do is stretch the line and go in. And that continues to be the issues that either because of the uncertainty or the level of illiteracy, not to say that in such a negative fashion, but if we don't have an understanding of what's being presented, we don't understand what the findings are, and we are confused and we can't comprehend that, then how can we have a level of understanding and embrace what is being presented within the scope and the paradigms of our organization? So again, it continues to be this level of confusion where all the guys want to do, all our personnel want to do is stretch the line and do what they, again, love to do, number one, but again, we're sworn to do because of their passion for the job and their degree of commitment to our civilization, to the public at large that they protect. And again, it's true from back in the day when we talk about the warriors of the 70s and 80s, and it certainly continues to be true here today. But again, we take a look at a clear distinction here. We talk about things of cycle. In 1932, the Fire Chief's Handbook was first published as a result of efforts that were taken up back in the mid to late 1920s. It was recognized at that standpoint through the International Association of Fire Chiefs Training and Education Committee that there was a need based upon the emerging insights of both science and technology and how they were impacting the modern fire service in the late 1920s, early 1930s. So 1932, the first edition of the Fire Chief's Handbook was written. And again, just some quick quotes here as I read through it. The firefighting profession has been referred to frequently in recent years, again, meaning the 1920s, early 30s, in recent years as a science in the broad sense of the term, and as practiced by the well-trained modern fire department, it may be so classed. Much constructive thought has been given the subject during the past 3 years, and out of this has come a fairly well-established procedure in combating fire. The great growth in the number of cities and state fire colleges and short courses has made a marked effort in the development and making uniform the operations of fire extinguishment. So again, just a simple element of the 1930s, almost about 90 years in the past, that we started seeing the earliest stages of embracing science and the fact that we're not making things up currently relative to what the challenges are. But again, as I mentioned earlier on, we continue to see some of those particular challenges go through a recycling process. Part of the challenges is this: when we take a look at our predictability and performance, the built environment is developing faster with greater complexity, with greater hazards and risks to our fire suppression or firefighting forces than the tactical models are providing for. And that is really the basis of our conversation. The built environment is developing faster with greater complexity, with greater hazards and risks than our tactical models are providing for. And that's where we get into, again, the whole need for performance-driven operations, a greater degree of literacy, a greater degree of both fire and building literacy, a greater degree of understanding of what we can implement from a operational modeling standpoint, a greater degree of emphasis placed on adaptiveness relative to modeling versus a more prescriptive approach, which is construction-based as we currently utilize, more greater emphasis on critical thinking, conservative bias, self-regulating discipline, and resiliency. Some of the challenges when we talk about our built environment, the issues dealing with social, economical, and ecological factors, engineered structural systems continue to challenge us relative to how our buildings are being built in such a delicate engineered aspect, both in terms of components, structural assembly systems, as well as the construction processes. Large area residentials, the mega, giga, and tetra mansions that we have classified as such, continue to be evolving trends in our residential structural area. The emerging aspects of mass timber or tall wood construction, cross-laminate construction, and the emerging concepts and application in the architectural designs of podium constructed systems and mixed-use occupancies. The emerging continuing trend of hybrid occupancy structural and occupancy systems, the continued use of light gauge metal and type 2 construction, adaptive reuse and renovation conversions of many of our older buildings, high-risk vacant commercial high-risk, large vacant commercial industrial properties, vacant and derelict buildings, both residential, commercial, and industrial, the uncontrolled illegal occupancy, the trend of pop-ups where we take our older row house, row frame buildings, predominantly in our urbanized settings, and literally pop the tops, take the tops off of our roofs and create an upward movement of newer construction where we have either existing or continued inherent construction on the lower floor areas. Started in the Washington, D.C. metropolitan area, and certainly moving its way slowly up the coast, and it's made its way into the tri-state area of the New York City, Connecticut, New Jersey location, and also starting to make its way up the coast to Boston. But again, certainly a newer emerging building type, occupancy type, as well as construction type. The influencing emerging aspects dealing with large area residentials or mega mansions, multiple occupancy types of structures, commercial hybrids, our small square footprints of our commercial buildings of 20 or 30,000 square foot or less, the adaptive reutilization, and again, the mixed utilization and emerging nature of the mass timber and low-rise hybrid type structures, both in commercial, business, and mixed occupancy considerations. Some of the trends and issues affecting the evolving fireground and demanding fireground, again, rapid changes in both building material methodologies and construction, aging buildings and occupancies, the evolving integration of engineered structural systems. Many of us continue to utilize the term lightweight engineering materials, but again, we have been promoting the terminology of engineered structural systems, of which there's a variety of different components and assemblies that have gone into it based upon emerging construction and building sciences. The influence of the fire load packages on our fire suppression operations, and the continuing trend and susceptibility of collapse and compromise in nearly all of our structures based upon the emerging trends of construction, materials, assembly systems, methodologies and practices, and their application to our built environment. Both the size and complexity, and certainly the fire department limiting resources and challenges that come about from that. Conflicting best practice and methodologies and modeling, again, drive us into a variety of different directions without any type of holistic or unified approach. Diminished or lost fire service experience, inadequate or plasticated risk management, inadequate pre-fire planning or incident planning and building intel, the lack of integration of building intel when it's readily available, just in terms of identifying an appropriate platform and the utilization of that technology in a world that's ready to be applied, but we just don't have some consistency in that. Many other times, again, we just don't know our buildings. We don't know the building construction. We think we do, but we don't. Ineffective collapse zone management, no building or fire literacy, leading to what we call historical repeating events, and the evolving construction sciences relative to methods and materials. The emerging trends, evolving building construction sciences, faster fire propagation. When we take a look at what we are learning about fire dynamics and fire behavior, the increased susceptibility of collapse and compromise relative to building integrity systems and components, decreased time to engage and our operational tactical windows, diminished occupancy, escape, and survivability in unprotected structures, narrowing windows for tactical engagement, increasing demands for efficiency and effectiveness relative to our human performance, and again, the continuing gaps relative to knowledge, skills, and ability, the technical competency, and those widening gaps relative to our building sciences and engineering sciences, And again, the aspects of education, experience, and then thusly the aspects of accountability, proficiency, rigor, and fortitude. Just a lot of moving parts when we talk about skill set levels. We talk about just being literate relative to those elements. Sometimes we have functionally illiterate commanders and officers who think they know what it is that they know about, but have no clue about what it is that they don't know. Talk about risk management, operational protocols, and templates, of which we will provide some suggested templates here in a few moments, but also some of the aspects of critical thinking relative to building anatomy systems, conservative bias regarding the concept of resiliency, integrity, and time, command modeling. We have some models relative to what we call the 5-star command model that all ultimately revolve around the following. The 5-star command model has taken the complexity of our built environment and assimilated and distilled it and filtered it down to 5 predominant functional areas or domains. Everything about a building and about an occupancy revolve around 5 suggested distinctive domains that we've identified and have been promoting and developing further in our modeling over the last 20 years. That includes construction systems and building anatomy. It also relates back to the concept of era and vintage. If we can identify and classify an era and vintage in which a building and an occupancy was constructed in, there is a cascading series of attributes that are highly predictable based upon how that building was built relative to its construction systems and anatomy, the occupancy type and risk, and then also the aspects relative to the quantitative portion of square footages, the volumes, cubic foot, the footprint of that particular building, the number of floors within that structure. How susceptible is that building relative to its construction systems, the era and vintage, regarding the most important distinction regarding building integrity during our conduct of operations, both within, around, underneath, or within the footprint of the geographical area of the building, and that deals with the aspects of compromise and collapse. Is it negligible or is it significant? It is something that may distinctively be overwhelming based upon the degree of fire involvement. And again, it's all associated back to the methods and the materials of construction that clearly are defined back by era and vintage. And then lastly, the 5th element deals with fire dynamics. It's how will fire and fire dynamics affect the compartment? How will they affect fire suppression capabilities and mitigation? But more importantly, as we take a look back down to the next level here of RIT, how is that associated back to resistance, resiliency, integrity, and time? So our modeling of our built environment relative to moving forward on today's Fireground, that again takes a look and utilizes empirical data, scientific insights, the aspects of architectural engineering and fire protection principles, all revolve around identifying and associating and looking at our buildings relative to 5 key domains, having an appreciation relative to the acronym of BEAR, dealing with building anatomy, the era and vintage, and the associated levels of risk that are further derived by a cascading degree of insights that provide a predictability of performance, and then certainly the aspect of resiliency, resistance, integrity, and time relative to fire exposure, heat impingement, how fire development within the compartment, how it may transition and affect the structure relative to the 5 components here, which ultimately ends up affecting the severity, urgency, and growth relative to our operations. So what is the severity of our conditions? What's the urgency and growth, both in terms of the building, the structure, the compartment, as well as the aspects of life safety? What is the urgency and severity and the growth potential relative to civilians that may be in distress? So it ultimately ties back into the common core elements of considerations and what may influence command decision-making and operational determination on the Fireground. I'm just seeing here where we are in terms of our context and our time frame here. One of the things that is critically important when we take a look at risk, and I'll talk about risk here in a moment to provide some connection of those dots here to provide some insights in the model. Do we truly understand risk? Well, there's 3 different types of risk when we take a look at our built environment and our operations within the structural realm of the Fireground. There are building risks that, again, we've provided some clarity and some insights to a certain degree, but what we are lacking is a holistic approach toward identifying what risk is. And I'll give you the precursor to that, and then what we've developed here as some of the moving forward with some of the best practices that have been born out of line of duty death insights and investigations. So there's building risks. There are occupancy risks. So again, it's not occupancy type, but occupancy risks. Couple of quick analogies toward that. Again, I can have a building that's built in the 1940s, that's 6,000 square foot, single family residential. And again, just based upon the characteristics and a simplistic connotation of that, that building has a certain level of risk based upon the inherent conditions of construction, the types of materials and workmanship that went into the building's anatomy, its susceptibility to collapse and compromise, its occupancy usage and associated risks, how fire dynamics will travel within the building. Again, 1940s vintage, 4,000 square foot, single family residential, but that level of risk is entirely different than another similar residential built in 2015 of 4,000 square feet, constructed utilizing a building anatomy or construction science system of a lightweight engineered structural components and systems, highly susceptible to a degree of catastrophic collapse. Again, we take a look at the kinds of workmanship, the kinds of materials that are being utilized, susceptibility to collapse, susceptibility to resiliency, integrity, and time. Each one distinctively has a different parameter relative to its performance, relative to time duration, and relative to operations. And that's what we are trying to move forward with, is trying to, again, identify elements that are driven out of science and engineering studies, the architecture profession, as I've been mentioning, the building sciences, the engineering, and the insights, both from the past and current, of our scientific basis, insights, and data, and apply them into parameters that can be utilized to change the game, to change the rules of engagement of assessing and reading the fireground, reading our buildings, having a greater appreciation of what that process may be that will hopefully provide insights, and it's highly suggested that may help provide determination on the decision-making process, at least influence decision-making processes, so that there is a greater degree of basis on factual or assumptions that, again, still have a basis versus just manually going to the efforts and moving forward and stretching the line and going in. So again, building risks, occupancy risks, and lastly, at-risk behaviors, which gets into the human component standpoint, which we feel is very, very important. We talk about those fundamental pieces, again, building, compartment, and company. Concept of predictability of performance, we've just introduced some of those relationships. They are truly, all buildings truly are predictable in their performance if we understand what some of those attributes are. Managing the levels of risk, the standards, the process, the templates, these continue to be some of the trends. Chief Alan Brunacini, again, introduced the fire service to the original concepts of risk assessment, risk engagement, the rules of engagement: risk a lot, save a lot; risk a little to save a little; and risk nothing for what is already lost. But again, it's somewhat arbitrary based upon how risk prone I may be and what my perception of risk is or is not. So when we take that a step further, we introduced the concept of a risk profiling matrix as a direct result of a line of duty death that occurred in 2012 in the city of Philadelphia. Double line of duty death. The report number is F as in Frank 2012-13. We developed, since there was a varying degree of basis of fire commanders and officers who did not have the ability to provide clarity on what risk was. You could have a senior firefighter, generically speaking here, you could have a senior commanding officer with 30 years on the job whose risk perception may be entirely different than a relatively newly minted BC or district chief that has, let's say, 10 years on the job. So again, it's experience, tolerances, they all have an effect on risk. So part of the challenge was, and the learnings and the contribution toward suggested recommendations, was a risk profiling matrix that we developed relative to the construction elements that we've been talking about. And again, it's pretty straightforward, looking at severity of risk, things that are, again, are negligible all the way to catastrophic that may result in personal death, grave personal injury, large scale destruction in perilous conditions, or something that's normal where we do have the associated types of hazards that are consistent with day in and day out firefighting. So if we can categorize, if we can classify, if we can represent what this risk severity looks like through training and through conditioning, then we can also identify through a very straightforward insurance-based probability matrix of what the probability may be for these types of categories. So it goes without saying is that if we have something that we can identify with and be able to assess and say, yes, this looks to be, based upon the degree of fire involvement, a fire severity level that's marginal and has a risk that is high or extreme. So when we take a look at the probability of events, it goes from unlikely to seldom to occasional to likely to frequent. And again, frequent just means likely to occur immediate or within a short operational time period, and it can be expected to occur frequently. Occasional may occur under normal operating times. And again, it's just a matter of correlating back to that. So again, we have been promoting this. My degree of involvement on the NIOSH reports as a technical advisement and working directly on a number of those reports, we've been able to, number one, the concept has been vetted through NIOSH and has been implemented within a number of reports that provides a basis. That first report was the Philadelphia Line of Duty Death of 2012, and it has gone on to be implemented in a variety of both building and occupancy types, just in terms of being able to correlate, look, this is what this category and probability is suggested to be. Here's what the events led to, and how do I correlate that? So we are still developing the concepts surrounding the aspect of the modeling, but this is integral toward our modeling concept. Just in the interest of time, I want to jump ahead a little bit here, talk about the model itself, and certainly try to maintain some continuity of our time frame. We talked about the relationship of performance of building, compartment, and company. That really becomes the key foundation in the first course of our modeling approach relative to, again, the building, compartment insights in terms of fire dynamics. And it really correlates back to where we normally send our personnel. It's what we used to call our compartment fires, room and contents, and their evolving aspect to structural fire conditions. And it's all about this company. Three critical interrelated components that all have a degree of relationship relative to fire suppression performance on today's fireground. The concept of building facts, first arriving, construction, tactics to safety is another layering of our modeling approach. And again, the high-level correlation here is that when we talk about building, compartment, and company, this is how the relationship was derived. Building performance relates back to the company, back to the compartment, of which all buildings have. Either they have one or many compartments, meaning rooms, large or small, which eventually become part of the building structure and that particular envelope. And again, there are varying degrees of resiliency as well as resistance that those compartments, based upon the methods and materials that are utilized, that are part of the building's anatomy. So hopefully you're following through this particular cycle. So when we take a look at the next level of component, we talk about the correlation of those operations. The compartment is where the fire originates, typically, unless we are dealing with a fire that originates in a void. But there is some type of compartment, whether it be a void compartment or, more importantly, some type of compartment space within the structure. So where the fire originates, it's where the company is going to eventually go in terms of our human performance portion, and it's where our engagement takes place. When we talk about company level engagement, again, we talk about the tactics that are being identified and employed regarding that engagement, and it's all about company capabilities, the degree of resources, and the correlating aspect of risk. So the risk may, again, be on a fluctuating scale. If I have a high degree of resources and availability during the initial conduct of a tactical window, that 10-minute benchmark standpoint, that level of risk may be more manageable, may be diminished. But again, capabilities relative to knowledge, skills, and abilities, the resource numbers, again, capabilities and risk is going to fluctuate. It may increase based upon a diminished number of resources of personnel on that apparatus, coupled with capabilities and limitations. So the correlation there is When we take a look at construction tactics and safety, there is a direct relationship of the building, the compartment, and the company, of which, again, in just a simplified high-level approach, these other elements are the correlations for them. The tactical methodologies and practices, again, we cannot certainly dismiss 90 years of refined tactical practices that, again, come about as a result of things that we've done in the field over this course of time. They certainly should not be dismissed, but certainly they should not be dismissed into the emerging R&D insights and making us more effective and efficient. They really need to be married into that consideration and aspect. One of the elements here that we clearly are trying to correlate, and again, our modeling has been based upon, is the aspect of naturalistic decision-making, or RPDM. Again, it's been around since the 1980s, but really is formative to much of how we develop condition tactical responses, our tactical edge, and what we implement in terms of our decision-making process and our engagement relative to our buildings. It's the degree of experience that's derived both from the past as well as current. It's the degree of awareness that we constantly are increasing, hopefully in a positive standpoint, even just by virtue of a class such as this in our session. We increase our awareness and hopefully couple that with our experience, our naturalistic decision-making, coupled with our other element when we talk about knowledge that we hopefully are increasing and combining. When we take a look at those elements and combine that with the insights that's coming out of science and technology, again, it's highly suggested that when we combine them, we have the relevancy back to our building, to our fire, and our company. So this is where we've derived and taken a look at how to connect these dots that primarily gives us what we call an adaptive fireground management model and concepts. The next slide here just talks about, just gives you a very high-level overview of a tactical benchmarking of our tactical windows, primarily looking at a 10-minute particular window of operation in our buildings. It's highly suggested, and again, it's really born out of best practices nationally regarding an operational period that really takes what's commonly thought of as being 20 minutes. Some jurisdictions and many other parts of the country utilize 15, but again, really best practices and what really is part of our modeling falls under the 10-minute window that primarily fall under the tenets of operations dealing with resiliency, resistance, integrity, and time, the concept of predictability and probability of building performance, the true consideration of compromise and collapse of our buildings, fire dynamics that relate back to condition tactical reflexes, understanding and implementing a higher degree of understanding of severity, urgency, and growth relative to fire dynamics, relative to building integrity and operations, and understanding high risk and high consequences as they relate to the human performance elements. And then lastly, identifying and adapting a more adaptive fireground management approach toward our operations. One of the things, and again, just this slide just shows you some of the timelines, and I'll just leave it at that as we get into the final couple of slides here of our program. Era and vintage is very, very important when we talk about our BEAR concept. The concept is derived from the aspect and correlation of architecture and engineering of what was developed, how different types of engineering and architectural principles emerged, the influence of codes that were established, again, in the mid to late 1800s, and how all of those create a certain dynamics of vintage and era, and even the terminology that we've utilized. And the best way to describe it is that Underwriters Laboratory utilizes in many of their reports they've discussed and talked about since their introduction of their first report, modern construction and legacy construction. However, the disservice that has provided, unfortunately, is that we cannot classify everything of old as being legacy construction. If we start correlating that back to the architecture and building and engineering sciences, we've come up with a terminology and relationship that all is based upon empirical and scientific and engineering principles and practices of how buildings were built, the elements that go back to the fundamentals, that 5 fundamental piece here when we talk about construction systems, occupancy use, collapse, compromise methods, and materials. There are different decades or periods of time in which these elements are consistent that give us what we call our predictability performance. So the cascading elements here are derived from our 5 particular domains. that are all driven by an understanding and classification and category by the different era and vintages that are derived from how buildings were built, how they were, what materials were being utilized, and then how they relate back to performance metrics regarding collapse and compromise, resiliency, integrity, and the aspects of time, which relate back to operational periods and windows. So again, you can start seeing this correlation of connecting the dots regarding operational decision making. And lastly, just the last couple of slides here is that when we talk about the suppression elements, we've introduced some concepts dealing with building facts, construction tactics, and safety. We've introduced a little bit relative to building performance, dealing with a compartment and dealing with a company. There's a direct relationship there. We've introduced the aspect and concept of building anatomy regarding systems, risk, collapse, compromise methods, and materials and fire dynamics, which are consistent with any age and vintage of building, as well as occupancy type and usage. But again, it all goes back to when these buildings were relatively built. That becomes part of that linchpin into that model. When we collectively put those together, it's all about what we are learning about that compartment relative to the aspects of fire dynamics. And again, although we have not discussed it in this settings, there is another element here that deals with the domain of fire dynamics profiling regarding behavior, growth, propagation, severity, and connectivity, the physical connection of a compartment relative to its building, its profiling, and its size. And it goes back to the concept of RIT overall to the building, of resistance, integrity, and time. When we take a look at those components collectively together, they give us an impact on performance-based tactics. It's really the formative basis of the individual components that give us a performance-based tactical approach and modeling versus a construction-based tactical approach, of which many of our current tactics are based upon. And then overall, this is the global image of the matrix of the individual components. And although we don't have the availability of time here, there's a direct relationship here in which we would show how each one correlates. But primarily, there is a working model that this relates back to, that they all relate relative to risk, fire dynamics, building anatomy, these considerations of operations, the company standpoint. There are other influencers, all of which, again, give us parameters. They give us performance benchmarking. They give us a model to assess, identify elements and attributes, help support the identification of performance considerations on the fire ground with a much more adaptive versus a prescriptive standpoint, due to the fact we have an emerging type of building and occupancy and built environment that are all being affected by the fire load packages that are affecting the manner in which our buildings ultimately become involved or become impacted by firefighting conditions and fire dynamics and fire behavior. It gives us a predictability performance that, again, is performance-based tactics that affects our overall operation. It gives us our model regarding adaptive fireground management. And again, it provides for the selection and implementation of best proven and predictable tactics that work best in your system. And primarily, the concept here is that you tie this into what an organization is currently doing, just enhancing its ability to identify, assess, and be able to provide the parameters of predictable building performance based upon empirical data that's, again, based upon how our buildings are built, both in the past as well as current, as well as going forward, but provides a clarity, provides a greater degree of distilled focal point on really 12 key factors here, 5 within the building anatomy areas, 5 others that deal with performance items, and then the 3 dealing with the issues of integrity relative to the RIT concept, which ultimately give us and should influence the strategic management and direct tactical engagement of our structure. So operational excellence, we talk about putting all of this together. The adaptive fireground management model, first and foremost, attempts to connect the dots with our built environment, takes a look at our 5-star command model, where again, we take a look at the 5 fundamental pieces of building construction as they relate to fireground related operations and the decision-making process. The incorporation of both building, risk, human performance, safety, and command. They are integral to everything that we deal with when we talk about fireground operations. And first and foremost, they are the significant elements of looking at the building and understanding the issues affecting both building performance, predictability performance, occupancy risk, occupancy characteristics, era and vintage, looking at the aspects of collapse and compromise characteristics, the influence of methods and materials, and ultimately the fire dynamics that go into the room and contents, the building and structural fires that we end up having. We incorporate our quantum tactics dealing with both fireground, building, compartment, and company. 4 key elements here that really help strengthen the model, especially when we take a look at the aspects dealing with first arriving, construction, tactics, and safety, the predictability of performance, the aspects that we've talked about regarding time management and how that has such an importance on today's fireground, more so than any other time in the history of the fire service. Time management as it relates to the predictability of building performance, the suggested elements of our model, and certainly the increasing aspects of risk management and how critical thinking as well as conservative bias play out in such a more robust and integral standpoint on today's demanding fireground, especially when we talk about the evolving nature of our built environment, the insights that research and development is giving us, as well as the demanding fireground when we talk about our operational standpoint and aspects. With that being said, again, we're pretty much out of time here for our short session. Hopefully you found some useful information here and have gained some insights on our adaptive fireground management modeling, the first arriving construction tactics and safety. Certainly want to thank the association for the opportunity to present. Really look forward to seeing you hopefully in 2022 face-to-face, where we can do a more engaging and a one-on-one type of presentation at next year's conference. So again, look forward to helping any of you that have some further informational needs. Just literally a phone call or email away. So thanks you very much. Take care and stay safe.
California Casualty has been endorsed by the MSFA for 10 years for its auto, home, and renter's insurance. It is our honor and privilege to protect those who protect our communities. Happy 10-year anniversary to the members of MSFA. Thank you for all that you do. For more information about our program, please visit www.calcash.com/MSFA. We look forward to seeing you at various local, county, and state events.